promised you 2 recursive algorithms. Let me show you the second one. This one's kind of clever. It was developed by a pretty clever guy named Gauss. He was a mathematician in the 18th century. You might have heard of, for example, Gaussian elimination. Question?
Sorry, going back here.
Yep.
Can you start with less than 4 multiplications?
That's, hold that thought. So what was Gauss's trick, Gauss's idea? Here's the idea. So again, it's, use this expression star and recursively compute 4 things. Notice here we have 4 recursive calls. So compute, first of all, AC as before. Compute BD as before. And now compute something kind of weird. A plus D, whoops, sorry. A plus B quantity times C plus D quantity. Which if we expand, we get AC plus BD plus AD plus BC. Okay? Now why did we do that? Well, here's the key point. Suppose we take the result of the 3rd recursive call and subtract the results from the first 2. What are we left with? We're left with AD plus BC. Why is that useful? Well, what do we really need? What do we really need to evaluate that expression star? Initially, we needed the values of AC, of AD, of BC, of BD. No, we don't. We don't care about the individual value of AD. We don't care about the individual value of BC. We need only to know the value of their sum in order to evaluate star. So Gauss's trick is to do only 3 recursive multiplications, not 4, to get all of the 3 pieces of information that you really need to evaluate star. Okay? Is that clear? So recursive algorithm number 2 would be, it's pretty much on the board. It would say, do 3 recursive calls, these are the 3. Do some subtraction, again that's easy. Subtraction is not going to be the bottleneck. And then plug it in, and then do the shifts by the necessary zeros, and then do the addition, and you're done. This is recursive algorithm number 2. What is intuitively clear, I hope, is that recursive algorithm number 2 should only be better than recursive algorithm number 1. Okay, it's true it's doing a tiny bit more work in the subtraction, but that's dominated by the fact, and we'll make this precise soon, it's dominated by the fact that it has fewer recursive calls. So of the 3 algorithms on the board that we have, the grade school one, recursive algorithm 1, recursive algorithm 2, pretty much the only thing which is obvious is that 2 is going to be at least as good as 1. But what's totally not obvious at all is which of these is the best. Is the grade school algorithm the winner? Or is one of these other proposals superior? Starting Thursday, and especially next week, I will be giving you some analysis tools that will answer, in particular, this question. More generally, will allow you to analyze the runtime of recursive algorithms automatically. Okay, we'll know the answer to this question just like that. See you Thursday.